Today I have chosen the topic called Z transformation. Already you are aware of the transformations called Fourier transformation, Laplace transformation. So this is another transformation called Z transformation. So Z transformation is a tool to solve the problem called difference equation. Next, it plays a vital role in the analysis and representation of discrete time linear shift invariant systems. And also it plays a main application in control system of engineering and also in some advanced statistical problems. So next we shall move on to the definition of Z transformation. See the definition of Z transformation. If un is a function of n defined for n equal to 0, 1, 2, 3, so on, etc. And if the value n is negative, then un will be 0. Un will be 0. Then Z transform of un is defined as, it is a notation, Zt is a notation, Zt, Z transform of un is equal to summation n equal to 0 to infinity, Z power minus n, un equal to, as you expand this as n equal to 0 to infinity, if you give, the function will be retained with the terms containing z alone. That's why we have given that notation as u bar of z. So next we will study the another definition called inverse Z transform. So if you just you came to know there here Zt of un is what? Zt of un is u bar of z. Now transfer this Zt to the right hand side. You are going to get Zt inverse of u bar of z is equal to un. This is nothing but called as inverse Z transform. Is called as inverse Z transform. Inverse Z transform is called as inverse Z transform. Now next we shall move on for the properties of Z transformation. So consider the property 1 of Z transformation. So Zt of Z transform of n power k is equal to minus z into d by dz of minus z into d by dz of Z transform of n power k minus 1, where k is a positive integer. So now we shall see the proof of this property. Consider RHS of this property. Consider RHS. So what is RHS here? Minus z into d by dz of zt of n power k minus 1. Now use the definition of, to prove this, use the definition of Z transformation. We know that what is Z transform of un? Z transform of un is defined as summation n equal to 0 to infinity z power minus n into un. So using this definition, in place of un we have n power k minus 1. So substitute that n power k minus 1 in the summation, in the definition. So what you are going to get? So it will be minus z into d by dz of what is Z transform of un? It is summation, start with summation n equal to 0 to infinity z power minus n. What is un? In place of un we have n power k minus 1. So now here I want to find the derivative of this. Here we can interchange the differentiation and summation. So interchange that term, minus z into summation n equal to 0 to infinity d by dz of z power minus n into n power k minus 1. So now I want to find the derivative of this term. It is a constant term here. You are required to differentiate only the term containing z alone. So differentiation of z power minus n with respect to z. It is of the form, it is nothing but derivative of x power n. What is derivative of x power n? N into x power n minus 1. So apply this definition. So it is of kx power n. So take out the constant term. So minus z into summation n equal to 0 to infinity n power k minus 1, as it is a constant term. Derivative of z power minus n is minus n into z power minus n minus 1. Z power minus n minus 1. Now take out minus z inside. So minus into minus plus. So z power 1. Z power 1. Here we have z power minus n minus 1. Becomes what? Bases are same. Add the powers. So by loss of indices we can write minus n minus 1 plus 1. So which is nothing but 1 get cancelled. 1 and minus 1 get cancelled. You are left out with minus n. Inside the summation you are left out with summation n equal to 0 to infinity z power minus n into n. Now similarly bases are same of n. Add the powers. You are going to get the powers are k minus 1 plus 1. So plus 1 minus 1 get cancelled. You are left out with what? K. So it is n power k. The problem is of the form now. It is z power minus n. Summation n equal to 0 to infinity z power minus n un. In place of un what we have? N power k, which is nothing but what? Z transform of n power k by the definition of z transform. So which is nothing but what? LHS. So hence it is proved RHS is equal to LHS. So this is the property called z transform of n power k can be written as minus z into d by dz of z transform of n power k minus 1.